Hi everyone, I'm Mahdi Ali Sabar, and in this presentation I'm going to talk about recent research in the field of adaptive facades. In the built projects, there are many dynamic vertical shadings which were utilized on south facades. It was surprising for me because we usually consider vertical shadings for east and west facades. Furthermore, the vast majority of adaptive facades usually restrict occupants' view connection to outside. These 2 points have inspired me to conduct this research. On the left side, you can see the details of base shading model which was utilized in this research. This is a multi-layer shading system which consists of 3 layers with a gap between them. The algorithm tries to change these dimensions in order to reach a balance between occupants' requirements and building energy criteria. Furthermore, a combination of cutoff and glare protection strategies were utilized to reach the research goals. As you may know that there are some metrics in the literature review to evaluate outside view, including lead view quality. According to the lead standard, in 75% of occupied area, occupants must have a direct view to outside in order to get 1 point. Furthermore, based on ASHRAE, openness factor is the percentage of open or see-through the shading fabric. These two metrics could be considered as the surface-centered metrics because they consider the whole space. But in our research, we need a metric whereby we could evaluate the quantity of view at a specific user position through a multiple layer shading system. Consequently, openness curvature factor was presented and developed based on openness factor. As you can see in this figure, for example, for base model, we don't have openness factor, while openness curvature factor equals 19%. Finally, openness curvature factor is defined as the percentage of openness in a semicircle within the occupant's field of view that's centered at the user's eyes. This could be calculated through this formula. Ladybug tools and octopus were used to do this research. The result of objectives for some optimum and worst models are illustrated in table 1, and you can see on the left side how algorithms change the size of some optimum models. Based on the simulation results, we concluded that a combination of openness factor and openness curvature factor should be taken into account to reach the optimum models. This is because the more the openness factor, the more the risk of discomfort glare through direct sun radiations. However, perforated and fabric louvers ought to be taken into account to reach a comprehensive method. In the next stage, without changing the openness factor, the form and size of some optimum models were modified with the objective of improving outside view. As it was expected, the value of openness curvature factor for all models increased, especially for model F3 by 4 times, as you can see it here, model F3 and modified model F3. Finally, Honeybee Plus was used to analyze the DGP value of modified shading F3 on the 21st of December at 12 a.m. for two view direction, 45 degree and direct toward outdoor as an extreme time hour. The figure illustrates the ultimate outcome of this research. As you can see it here, the generated models in this research could provide an acceptable amount of outside view compared to common shading systems, including Venetian blinds, ruler shades, and also origami-based shading systems, which usually block the outside view at extreme time hours, while they could keep the amount of DGP in imperceptible range, as you can see it on the left side of figure. Finally, the main research findings are presenting a new metric, openness curvature factor, contribution to the knowledge of adaptive facades, and presenting a new approach, a new method to design adaptive solar facades. And this method could be used through a form finding process in order to generate some optimum geometric or also complex non-geometric shapes, which could provide more outside view and keep the amount of DGP in imperceptible range.